Okay, so I'm Rocky Bernstein. I work for Consensus, which has nothing to do with Perl. It's a Ethereum-based company, and they're way cool. I work remotely with somebody in Thailand and somebody in India and somebody in the Netherlands. Working remote is really cool, and it's a really cool company. All right, I don't want to. So, how many people have found Waldo in here? Yeah. Okay, no, that's fine. But I sometimes feel like I'm. Yeah, I see him. I sometimes feel like I'm like this guy when I'm trying to debug an error. And computers are really good at computation and all that, and this is one area that I feel that they've been very weak. And I make a lot of mistakes. I'm very fumbling, and so so the two talks I'm giving, you can see how somebody who's very fumbly and makes a lot of mistakes, this is the kind of code that kind of person would write to compensate for my own deficiencies. But I think I hope others can benefit from this. Okay, so here's a Perl error. Uninitialized value prev at array element. Okay, so the question is which prev? Some other examples? Does that work? No, that didn't work. Which prev? Oh, okay, good. Right, uninitialized use. Okay, and this is I don't know. Oh, I see. I have to do this thing here. Okay, so you know, dollar underscore is used an awful lot, and it could be any one of those places. And finally, this is my favorite: use of a private variable in void context, and it's just in a val code. How many people have actually, had an error in a val code? I know you're not supposed to use a val code, but yeah, okay. And how many people have found it fun to debug a val code? Perverse. Okay, you. What? Oh yes. Okay. This is a sadist. Okay. Okay. So now let me bring you back to. I promised to give this quote in a late edition. Right. We encourage you to develop the three great virtues of a programmer: laziness, impatience, and hubris. Okay. And how does that apply here? Well. Laziness is the quality that you expect to get to reduce overall expenditure. So most of us probably couldn't write Perl. Larry Wall can, okay, but he says that he wrote it to reduce, so that he could be lazy and he didn't have to write awk, cut, grep, and all of that. You bind it so you get somebody who's really good at doing this kind of thing, and it saved him a lot of time and possibly saves all of us a lot of time. That's the laziness aspect. And how does that apply here? Well, I don't want to go figure out which one of those. For you, maybe this is in your talk, but I don't want to spend any effort figuring out which one of these 2 or 3 times places. I gave this talk, a version of this in Python. I've done this in Python as well. Okay, and invariably what the first question was, why bother spending all that effort? Okay, I guess what I'm trying to say is this really is part of the, according to, if you buy the tenets of Larry Perl, this stuff is in line with his principles. And impatience, the anger, and this is definitely me. The anger you feel when the computer is being lazy. The computer does know which one of those 2 places. Okay, it's not like the information's been lost. Okay, it really knows where it is. If it were just directed to tell you about that, that would save you a lot of time. Okay, so let's see. So now we got to go into a little bit of the nitty-gritty of how this stuff works, and I spent too much time at this, but a lot of this is just kind of an algorithm-y kind of thing. How many people are familiar with compilers? Okay, good. You'll be quizzed. No, so you write that, and according to Beacons, how many people can read this? Okay. So explain to me why this number is this number plus 1. I mean, it looks slick, but but that I think that is always the case. This number here is the actual. This is concise has many options. This is the option to show this as a tree. If you're to show it as a linear sequence in the way that it's actually written down in memory or whatever the instructions are laid out. So this thing at the top is really the last instruction. This one here is really the first instruction. And you can see it skips. So we go 1, 2, then we get to 7, right? We skip, and 5 and 3. Anybody want to venture to explain what's going on there? No. We'll get to that. And so all I wanted to say was that, let's see. So that's the op tree. Right. If you actually do this, you'll get extra garbage in this. That you'll have instructions that were replaced by other instructions, and concise actually shows this. And so this is a little bit more concise than concise shows, but no information has been lost. Right. And next. So okay, what does next state do? Okay, next state is basically saying all these instructions underneath are associated with that, and so you can see that it's got the file name and a line number. So this is in function main line, okay, and everything until the next state is in fact associated with that line and file, right? And so right now you can see, I could be here, I could be there. So the problem is, right, I could be at this divide or I could be at that divide, right? And all these instructions are associated with that one next state. And that's what we're trying to do is get a little bit better. And now that I've given you the secret, you probably do the rest yourself. So, but I'll continue. Right. Okay. So now we come down to this was the part that kind of thrilled me, was to tie this down again to Perl itself. And Larry Wall is a language freak or whatever. A linguist, I think he would call himself, and this really is so I've been doing this in this language and other language, and this really is a language translation problem. And if you think about it more as a language translation problem than a traditional parsing problem, for me it's been much more helpful in order to make headway. So okay, so here's Gaelic and here's English. And if we look at the correspondences here, whoops, yeah. And so you can see that there is, so some of these words are flipped around, like these two, and this one's combined, okay. And you spell haggis differently. Right. So just get familiar with the idea that sometimes words switch around. In that previous example, did anybody? There was an example. The reason I did this is there was an example of something that was general that became very specific, and that's why I wrote the Gaelic before the English. Anybody know what that was? Something analogous here. It's this right here. Okay, this $A could have been a my variable or a global variable. This says, who's the guy who knows it? GVSV. Anybody know what that means? That stands for a global scalar variable. So this is not a my variable or a local. It's not a my variable or an our variable. And so you get that with get Gaelic, right? And this could be any one of these three things, but in English we have to use that. And in IME it could be either of those, but it's I here. Okay, and okay, and so that thing where I said we have the next state and you have a bunch of lines, and so you've actually seen this kind of thing that goes on in Perl and line numbers, and whenever you look at any simultaneous poetry or whatever, right? And so you kind of know that these two lines, right? That paragraph is roughly equivalent to that. And in this particular case, this line is like that. and that line is a translation of that, or to the best that you can do. And although I don't find it fun, I've played this game where, okay, the address is at the end, so, maybe it's, right, I have face, so, or let's take Sansi, right? I mean, they're both second to the end, okay, maybe that's the way it works, okay? But it can get funky. So here's a side-to-side Perl translation. And now, yes, now I've written them, I've dropped the tree thing, I've written them in the normal order, in the instruction order. And so you can see we have that jumbling around again. So this first token is X, but there's X there. Okay, here's the assignment, but that's now at the end. And so with these parts of the puzzle, what's this called? Polish prefix notation? Okay, and the advantage of a Polish prefix notation is for interpret. So one of the languages I'm now working with, so I'm now working in the Ethereum space, but if you look at, there are old languages like Forth and HP calculators and PostScript. But a modern language that still sticks to that is if you've ever looked at Bitcoin and Bitcoin script. That's also in reverse Polish or Polish prefix. And anybody want to guess? Anyone want to explain why that might be a natural kind of thing?
It's a stock machine.
What?
It's a stock machine.
Well, okay, and that's correct. That's correct. But the way I think about it is it makes it easy for a stack machine to work, so that by the time you get to the operator, all the data is there. Okay, you don't have to say, okay, I have an operator now. Go find where the data is. So right, so you could still have a stack. You could have a very sophisticated stack machine. I think, that did this stuff. But it's natural. It makes it very simple. Okay, so now that we explored the human translation aspect of it, so when I write this, so now I'm going to show the translation. So when I write this as text, as a tree, right? Again, these are the instructions. Well, sorry, this is the instruction order, right? I'm going to, for my purposes, so I started with B to parse, and I wanted this exact location, so I had to extend it. And then I got to that stage where there's 5,000 lines, and it was a pain. So I said, let me see if I can try to refactor it and make it better. And in particular, I need to keep around. I need to create a hash of these addresses and pass around information, extend the information that's there. Okay, so we can think of these as memory addresses, even though they're instruction orders. But you'll see that there are only two kinds of nodes. There's a divide node and there's a GVSV node. Again, this is compiler stuff. In order, so here's the translation, and it doesn't take that much imagination to see what's going on. So the GVSV somehow is picking out the name. The divide is somehow taking the left and the right and slapping a divide symbol in between, but the important point here is that at every single instruction, I can tell you what that computation represents, or where like so as I'm walking along and I'm at 3, and you say, where am I? Okay, you're at A. At instruction 4, you're at B. Once you get to 5, you're at A divided B. And notice the difference between 5 and 7, right? So now I can tell you which divide you might have hit an error on. Okay, so these are strings. And so here's code that kind of does that. And so now we're going to get a little bit more programmer oriented. And let's see. So oops. Now I'm lost. Divide rule up. The way what I wanted to try to get across here is that there's a local there's a rule. You can put code for each of these nodes based on information that you get coming down, inherited attributes, or information that you get from the children. But you get information from children and the parent, and you can write code for each of those nodes. And so this is actually a very, very simple version of that code. If you actually look at bdeparse, you'll see something much more complicated. But this fits on the slide and it gets across the idea, which is that, see, so I'm passing down this self thing. And this context is also passed down. Okay, this context. Oh, let me not explain that right now. But I guess op is the op tree, right? So what I'm doing is I'm sort of recursing. This was called by deparse. I'm recursing, and we're going to try to get all the information from the left child, and that's going to come back as a string. I'm going to try to get all the information from the right child, and I'm going to put these things together. And there's actually, and this is where context comes in, is if my parent happens to be have higher precedence, operator precedence, right? So if this instead were plus and my parent had divide, then I think I'm okay. No, then I might have to put parentheses around this thing. Okay. Okay, and the GVSV rule is also is also very simple, but we have that same kind of thing where, okay, remember I said it could be a global variable or a my or our variable, and so there's actually code that looks in the op tree to figure out which one of those two cases it is. Okay, as I said, there's 5,000 lines of this stuff, and then another 1,000 of documentation, but there's 5,000 lines of this stuff, and so it really pays to try to compress this and make this simpler. So how do we do that? Well, domain-specific language, and again you've probably also seen this, if you write reports, right? So I wrote this, and this is actually longer, but I argue that I actually like this one a lot better. Why do I like this better? Because it's clear that you gather data first, and then you format it, okay? And in this kind of thing, it would be very, very useful to, if you actually look at the bdeparse code, they have those things interspersed. So you're gathering a little bit of data, putting it in a string, gather some more data, add that onto the string. When you finally get down to the end, of doing stuff, you really don't know. I'm sorry, what? Love what? Oh, yeah. Well, Perl 6 doesn't do op. Okay. Okay. But I should say that none of this will work in Perl 6. Perl 6 doesn't use op trees, op tree, and all that. And I hope. Do they have a deparser for? Is there a bop for Perl 6? Okay, good luck. No, look at the talk for what I did on Python to see what you have to do. It's doable, and I think it's interesting, and it should be done, but it's a lot harder. So but okay. So I was at gather data and then format, and so since I'm actually passing down a tree to keep information, I can't use %s. I use %c. But I've written a little template code there, and so you have to know a little bit of jargon. But this to me is just a line and a hash table, okay, instead of all that other code, okay, and it's just saying, child one, this is saying, okay, I'm going to recurse down the children, right, and these are the the indexes of the list of children, and this thing has precedence 9. This particular rule has precedence 9, and 19. And you go figure out if I have to add parentheses. Okay, so now what? So now let me get into the lingering problems. And so we saw with Verfa, you're honest, right? Becomes this, right? So if I say you're at the word 2, where are you in here? Anybody would like to venture a guess? Yeah, well, good, because you can't. Okay, I think the best you can do is just say that all of this, we have to go back to the line kind of idea that all of this maps into that, and within that, you know, no clue. Right, so blah, blah, blah. So where am I? Far from honest. If we're reading 2, where are we in Gaelic? Okay. And so, name, somebody who said that they knew this stuff, name the operation, an opcode in there that doesn't have a corresponding thing in Perl. It's PushMark. I would assert it's PushMark. Okay, PushMark is a stack changing operation. Okay, and so maybe sometimes there might be a set brace. Okay, but I think in this case there isn't. And so if you actually look at bdeparse, as you've done, you've probably noticed that there are a lot of comments that say skip PushMark. Okay, and that's what's going on. So lingering, right. In this case, there wasn't. There was this parentheses. Okay, so in this case, and I'm sorry I don't get into all the icons, but when I use a vertical bar in there, I'm just saying this is kind of it means that this operation, this PushMark operation, doesn't really have a course translation. Okay, and so now the last. There's one other lingering problem, and this if you go to Stack Overflow, this is a problem that's existed for 16 years. A person who says, well, this will probably exist for the lifetime of Perl. I doubt that this will ever get fixed. And what's going on here is we call this print line. So Perl has this interesting thing that so after you do a call, the PC advances. While you're inside this routine, the program counter or the op counter is already on for each. Okay, and there's no next state here or anything. So it will report that you're on line 1. Okay, the last thing is just a little. I have to do that. Okay, and this is 1 minute and 20 seconds. If I click this right, is it clicking? Is it working? Oh, I have to somehow go over here. Okay. Now is it working? Well, is it? Is it moving? Okay, now it's going. So this is a debugger that uses this kind of stuff. So there's, and it's running inside of Emacs using an interface that I wrote. It's called Real Good. And so I'm going to set a breakpoint in this line 5. I augmented a standard fib with count so that I could just stop at some arbitrary location. So I'm stopping at, I'm breaking if line is count is 3. Continue. So now you can see I'm at that line. And first run a backtrace showing the source. Right. So sorry for the rainbow colors. I didn't have time to fix anything. And so here, this is what this thing does. Right. And so, I mean, I waste a lot of time moving the icon around, and I don't know how to stop it. But this gives you an idea that how this could be useful, and that's basically it. And finally we'll go on to the links. So I really haven't covered a lot about this, but the CPAN is here. That thing that I was using is a plugin for the debugger I wrote called Developer Plan. I'm talking about that later. And what I wanted to get across with these links is that the Perl community is kind of awesome. There's a blog for Perl. I mean, CPAN is cool. Cool. And there's a blog for Perl, and that's cool. And I got this idea, from Perlmux, from a guy I don't really know the name of. And if you want to figure out how to do this in Perl 6, look at that, and it talks about the issues of how to, because in Perl 6 you now need to recreate that parse tree, that that it's not an abstract syntax tree, but it's a syntax tree. And that's it. Any comments? Shoo.
Laptop, but you're here next anyway, so.